For me, I do not have RStudio on my local machine. I tend to like RStudio Cloud a lot. I just discovered it some weeks ago, and so if you have issues setting up RStudio on your machine, you could check it out. I think it's just rstudio.cloud, and then you can sign up and just play your hands around it. So that's what we are going to, well, that's where I'm going to be doing this from, because I don't have RStudio on my machine at the moment. Okay. So the first thing we'll look at is the simple linear regression. So basically, we are going to build two models: the simple linear regression and the multiple linear regression. I understand that there's a speaker who is coming to take into details the nonlinear regression. So I would kind of leave that. And even with the linear regression, there's still someone who is going to kind of go deeper. Mine is just an overview. So kind of just to give you some of the things people would expect that you know before attending their lecture. Okay. So in this simple task, we are going to use the cast data set in R. So you can just run this in your RStudio head by trying to view the first 5 rows. You can use the head of cast, and then we see that this cast data set has 2 columns: the speed and the distance. So we kind of want to know the relationship between speed and distance. So we are kind of going to fit a line or find the best fit line for speed and distance. Okay. Well, these are usually, by the way, is there anyone who is kind of a first timer in R? Like if you don't have it installed, you've not attended anything in R before or used it for anything, just raise your hand. Let me see. Oh, cool. I see. So we have a point. Okay, cool. So then I think it would be better for us to all be set up. So we have some people who haven't used R before. I'm going to copy this. Okay. Sorry for that. So open a browser and type rstudio.cloud. That's if you don't already have RStudio on your local machine. And then you sign up. You click on sign up, and then yeah, for me, I've already signed up, so simply trying to log in would work. So I'm using the free version. I'm not going to log in, by the way, but that's where you can get started. So when you are done signing up, it will display something like this, and you can kind of create a new workspace, and then you can just have this working. Let me know if you have issues along the way trying to sign up and get it to work. Okay.
There is somebody here that has an issue.
Okay.
Please
Yes.
direct your issue to the chat group, and I will attend to that. Please,
Okay.
please.
All right.
Okay. So, yeah, like I said, I do not use R Studio on my local machine. I pretty much use this R Studio Cloud. So once that is done, because the data is already, by the way, Joshua, I have some data. How do I get it to the people before we reach the second part?
Okay. You can share that with me. I will send it on the Google Drive for them to just, you can just get it while we are talking right now. Just share that with me. I'll do that.
Okay, via WhatsApp.
Yeah, you can share it with me by WhatsApp. Yes. So I will download and share with everybody on the Drive.
Then I guess let me stop sharing and do that. Then I'll
Okay. Okay.
share my screen. I hope the one who had an issue is now able to handle that. Is there any issue again?
For now, from the chat group, there is no any issue. We only have people who are first timers, and I've given instruction on how they can have access to the R Studio Cloud.
Okay.
Thank you.
All right. So I've shared with you now, so
Thank
you
you.
can.
Okay, go ahead, go ahead. When it is time, I would have shared that to all participants.
Sure, sure. Share my screen. Good. Okay. So this command is used to kind of view the first 5 rows of your data. And like I said, we have speed being one of the columns, and then we have distance. So in this data set, we want to fit, like get the line of best fit for this these two variables, just like I showed in the slide. So we fit a straight line to these two and try to get the line with the minimum error. Okay. So, and this is also used to kind of check some basic statistics of the data. So through this command, you'll be able to know the minimum value of each of the fields. So we have the speed having so on and so forth, the median, mean, third quarter, the maximum, and so on. Yeah, so generally when it comes to R, we are all beginners. I mean, I'm also beginning with you. I've used R before, and I kind of transitioned to Python for over 2 years or so. And so, yeah, but I'm through, because of this exercise, I've kind of come back to just to ensure that everyone benefits. If not, we would have been doing this in Python. Okay. Then we could draw or plot or do a scatter plot of this data with the speed being on the x-axis and the distance on the y-axis. So pretty much this will do for you. There are various ways of drawing a scatter plot. in R, but I find this quite okay. So scatter.smooth, you would have your X. So you specify the X, which is the car's dollar. Is this dollar? Yeah, speed. I have kind of forgotten the terminologies in R, so I don't know how you, for instance, mention this. Joshua, any help? So
Okay,
car,
okay, cash, dollars, dollar speed.
okay,
That's to index the variables we have stored on the cash dataset. Speed.
yeah.
Okay.
So car's dollar, right? Car's dollar speed. So this is telling R that the X variable.
Sorry, please. I think you should make your screen visible. It's your face that we can see rather than your screen, so that everybody can see it very
Oh,
better.
are you not seeing my screen?
We are
It's
seeing
not.
your
It's not
screen.
clear. It's not clear here.
Is it maybe a
Your
problem
screen
with
is
internet? Because I
no.
can
Your
see it
screen
clear.
is smaller, but
Oh,
his
I can.
face
You
is
should
one of the
double
white
click on it.
screen.
The adjustments is from your own hand. He can enlarge the screen you want to see and then reduce his own picture.
Thank you.
Oh yes, yes, I've seen it. Thank you.
Mr. John, go ahead. Please, sorry, before you go ahead, Mr. John, I don't want interruption, please, so that we can enjoy this particular training very well. When you have any suggestion, just unmute. One person talks at a time. That is on a condition where your issues could not be attended to on the chat room, please, I beg. So that our speaker will not be distracted. So that it could be in the, right perspective to discharge to us what he has prepared, please, I beg. Thank you. Mr. John, over to you.
Okay. So is it okay now? Are you able to see the text?
Yes. Yes.
Okay. So the X variable we specify to be the car's dollar speed, which is saying when you pick the car's data set, look for the speed column, and that will be our X variable. So for the X-axis, and then for the Y, it should pick cars and look for the distance column. Yeah, and this is kind of saying what the title, okay, distance versus speed, okay, and you kind of have it this way, so you see the data points. This line is kind of trying to show kind of a best fit line, something like that. So you can already have an idea of the fact that there's a linear relationship between the two variables. This data is already clean, so we are not going to do a lot of pre-processing. We are just going to go ahead and split our data into train and test and fit a basic linear, simple linear regression model to see how it performs. Okay. So if you can see here, we have set.seed 100. So what this is saying is that it should kind of stabilize a random state such that when different people run this chunk of code, they will all get the same result. So we are trying to sample 80% of the data for our training and then 20% for the test. So it's going to randomly pick some rules, okay? So we want to kind of stabilize the randomization, the sampling thing, so that everyone who runs this chunk of code will get the same result. Okay, so the first line, the second line, row index sample n1 to n row of cars. So we will just want to know the distance, I mean the number of, you know, rows in the data. So we kind of just want to know the number of the length of the data that we are sampling, because we are going to use it here. And so for the training data will be the cars data, for the length rows from this value row to the 350th row, and picking all columns. So that's what it means. And then our test data will take the rest. Okay. Good. So one thing you can do for me is to well, just do this for me. View the first 5 rows of the training set. I'm sure you can all do that, because we already did something similar on top here. Head of cars. Okay. So now we have a different name for our training data set, which is training data. So we just want to view the first 5 rows of this data. So I guess everyone would have had heard of training data. So the good thing is that it will already suggest the name, so you can just press enter and run it. Okay. Yeah. And you can also check the tail, I mean the last 5 rows of this data set, of the training data set. So for that too, you can just use the tail function to view the last 5 rows. By the way, is everyone following it? Is it okay? Am I too slow, too fast?
We're enjoying you, sir.
Okay. Okay, so this also gives us the last 5 rows of the data set. While we are doing this, I'm also ensuring that those who are new to R, we kind of have this basic syntax to start with. Okay. And then we come to the model. So we want to now fit our model. Let me remove this. Okay, so this line, so we want to fit a simple linear regression model. Simple linear because we only have one independent variable and one dependent variable. Let me know which one. Okay, so in this case, speed is our independent variable and the distance is the dependent variable. So we want to know if someone is speeding at a certain rate, what is going to be the distance covered? Like, so what's the relationship, kind of? And so in R, Joshua, I think there's a hand raised.
Okay, I can see the hand. I'm trying to even go ahead. Go ahead.
Okay. So in R, all that we just need in order to fit a simple linear regression is this kind of syntax. So forget about this part. All we are doing is what? Assigning the result to a certain variable. So you can ignore this. But if you want to actually have control over the model so you can see more insights, then you can assign it to a variable like so. And so all you just need is LM into brackets. What are you fitting against what? So we have our distance, which is the dependent variable, and then speed being distance being our independent variable, and speed being our dependent variable. And we specify the data. So data in this case is now going to be the training data. So, hi guys, what do you think? I'm kind of trying to figure out which one do you think is the independent variable and which is the dependent? Speed and distance. Any ideas?
Okay, we have the dependence to be the distance based on the model, the way you have written your model.
So the dependent is a distance.
Yes, yes, based on the way you have written your model.
Oh, so like, but does it make sense in general if you have this kind of two variables? You want to look at the distance that will be covered. Suppose you are traveling at a certain speed, right?
Yes.
So speed is not depending on distance. So
yes, distance depending on speed.
Correct. So this is why distance is a dependent variable, and then speed is our independent variable. And so our data, we specify the name of the training set that we already did here. There's also various ways of splitting your data into train and test. You can look at that. So probably for an exercise, you can give me another way to kind of split your data into test and train. In this case, use 75%. So I would want to see that when it goes to the exercise section. So take note of that. Now that we have our model fit, first of all, let me bring this here. So we already gave our model a name, LM model. So we want to see, like, get more insight to it. So when we use the summary function and put our name, the name of our model, it will kind of give us the detailed information about the model. Good. So as we can see, they give us the function name, okay, the formula, which is the distance against speed, and the data is just like we specified here. Okay. So there are a lot of things here. If you are interested in the stats, there are a lot of variables here and their meanings, interesting stuff here that you can look to gain some confidence in your model or not. So I will be going back to the slide just for us to look at some things and come back. Okay. So we did say that some of the things you can look out for after you build your regression model, whether linear, simple, multiple, is to kind of look for some of these things. So R squared, the higher the better. And we say that if it's greater than 0.74, We also have F statistic here, the higher the better. There's T statistic, which we can go and look at. So this should be greater than 1.96 for the p-value to be less than 0.5. So we can go back in. So F statistic in the slide, the higher the better. Okay, so then T statistic. So we can just go through the details and compare to whatever standards you want to use in order to make a conclusion. But in general, the idea or the hypothesis that we try to either accept or reject is that there is no relationship between the dependent variable and the independent variable. So this just means that, one, we said that y is equal to mx plus c. Okay, for a simple linear regression. I just want you to have some intuition. So what the null hypothesis is saying is that this m is 0. So there's no supposed to be any relationship between y and m. Okay, so in this case we are trying to see if there's significant if the p-value is kind of greater than 0.05, then what would we be doing when your p-value is greater than 0.05? What do? Do you reject your null hypothesis or do you accept it? Any ideas?
What do you say? John, go by it again.
Okay, so we have a null hypothesis that says that there's no relationship between the dependent and independent variable.
Okay.
And now, suppose our p-value is greater than 0.5. What do we do?
So we accept the null hypothesis that there is no relationship.
We accept the null hypothesis that there is no
relationship between.
Good. And if it is less than 0.05, then we
reject the null and we accept the alternate.
Correct. Good. So coming back here, could someone assist me in finding the p-value?
Okay. 0 point is one 1 point below, yes.
This one?
Yes.
Good. So this is kind of way less than 0.05, right?
Yes.
Because this is 1.848 and e to the power minus 10. This is kind of, correct me if I'm wrong.
You're right.
Good. So based on this statistic, what do we do to the null hypothesis then? It means that we would be rejecting the null hypothesis that there is no relationship between the y and x. Therefore, there's a relationship. Therefore, this model is kind of significant. We can also look at other things like the F statistic. Suppose we had two models, then we could compare these values and see which model performs better. The adjusted R squared, all these kind of are important that you can look at. Okay, good. So that's it for this one. Okay. Then we can predict on the test set, the test data. So we can now use our model to predict what the distance will be for the other test data points. And so running this can give us, so we already have our predictions on in this variable. So an assignment is this. Now we have, we already know our distance, the actual distance, the actual distances, okay, in the data set. Now, we also have predicted on the test data set using our model. So we have kind of the predicted values in this variable. Okay, so let me see what my curiosity would let me do. I'm not really sure, but you can give me some ideas. We are learning together. So Joshua, I want to see if I use head, is this going to give me, is this a list or something?
Let me see what you're doing.
So I want to see what the model has predicted, the first 5 predictions. Is this going to give me anything good?
Let's try it, but I doubt it. Good.
Okay, what are we getting here? Okay, so I guess what we are seeing here, I'm coming. So for our test data set, let me print the first 5 of the test data set so we can see something. Okay. Good. So well, probably this is not how we can unpack the predictions, but so the assignment is, we kind of now have predicted on the test data set. So how do we visualize? How do we kind of put the 2 columns side by side? Okay, like we have the actual observed distance, and then we have the predicted distance. So we want to have a table where the actual y will be on one and the predicted y will be on the other, kind of. So this would be something you try to do either after or during the break time. Okay. Yeah, so basically this is how do we put these two in a table? Yeah, but if you have an idea now, you can just bring it on board so we can all do it together. But if not, we will leave it here. So basically, this is a simple linear regression model that we have just built, and we've seen that there's a significant relationship between distance and speed. So we reject the null hypothesis and accept the alternate. Sorry for that. Okay, good. At this point, if there are questions, I will be happy to answer them. If not, we move to the part 2, which is going to be the multiple linear regression.
Excuse me, please, before you proceed, I don't seem to understand what just happened here. Hello?
You don't see? Yeah, hi.
Please, I don't really
Come
understand.
again.
Good morning.
Good.
Please, I don't really what you just explained. I don't know if you can go over it again.
Okay, this one. Is it this part?
No. From the p-value thereabouts.
Oh, okay, cool. Okay, so I was just trying to go a bit statistical and let us know what we are trying to do by fitting a model. What are we doing? How do we test the significance of the model? How do we know that our model fits well on the data and whether we should use it or not? Okay, is that clear? So let me do this like H naught. Between distance and speed. Have you seen this? So that's
yes.
The null hypothesis says that there is no linear relationship, okay, between what? The distance and the speed. And the alternate, is it alternative or alternative? So it says that what there is, okay, there is a relationship, simple. Are we cool with the, pardon?
Okay, how did you know if there was a relationship and if there wasn't?
Yeah, so we will get to that. But now I want you to tell me, are you okay with this, the null and alternative hypothesis? Do you agree that? Do you agree with these two?
But I don't even know how you figured that out in the first place. That's the problem.
No, this is a statistical question. Okay.
Okay.
So it's a statement. Okay. The null hypothesis says that there is no linear relationship. So that's the assumption. So before you even build a model, this is what is there. This is what is believed. Okay. That there's no relationship. Okay. And what you try to achieve is to prove the fact that this is rather true. Okay. Or not. Okay, that's what we are trying to. We want to know whether to accept this assumption or reject it and take this.
Okay.
Okay. So once that is agreed on, so we have built a model which try to kind of fit a linear function on this data set. Okay, and we can see the details of the model here. Okay, now in statistics, if you have your p-value, okay, if you have your p-value, don't worry about the p-value. I will show you where it is. If the p-value is less than 0.05, let's use a greater than first. 0.05. What do? You accept the null hypothesis. You accept H1, H0, right? Correct me if I'm wrong. Joshua, are we on track?
Yeah. Well,
Now, if the p-value is less than 0.05, then what we do is what? We reject the null hypothesis. Yeah, we reject H0. In that case, we are now going in for what? H1. Okay. Are you okay with these two? Before I show you where to find p-value.
Yes, I understand this.
Okay. Now, so in your, when you display the details, the summary of the model, it gives you a lot of things, but this is where you can find the p-value. It's here. Can you see it?
Okay.
Okay. So this value is giving us, let me try to expand it. So this value is giving us 1.848.
Well done, sir. Well done, sir. Sorry, please. I'm having a different result. I'm sorry to cut you short. My result on the residuals, the minimum first quartile, median, and third quartile are totally different from what you have on your screen, sir.
Really?
Yes. I'm having, for the minimum, I'm having 29 minus 29.069.
I see. Probably this is not useful after all.
Probably I've messed it up.
Yeah, probably the seeding is not useful because what
Okay, the set speed.
Yeah.
Okay,
Who
I
said
guess
this?
I missed this part. I think I missed this part, actually.
Okay.
Okay, let me quickly input it.
Sure. So this value here is actually going to be 0 point, and then I think 9 zeros. 184. Am I right? The mathematicians here. Okay. Do you agree with me that this value is way less than 0.05?
Yes.
Okay. Now we have these conditions. What do you think we should do to the H0? Tell me.
We reject it.
We reject it. Okay. So if we reject it, what does it mean?
Okay, if you reject it, it means that there's no relationship between distance and speed. There is a relationship between distance and speed.
Good. So if we reject, it means that there is a relationship between distance and speed, right? Right?
Yes.
Good. So that is why we are concluding that based on this statistic, then the model that we just built is significant. It means that it is useful since it proves the fact that there is a relation between distance and speed. And you can see that the value is very small, close to 0. Okay, this is very good. So it's that strong because if it were to be greater than 0.05, like approaching 1, then there is no relationship. Yeah. So it means that the relationship is strong, which is why we are rejecting the null hypothesis and kind of going in for the H1. Are we cool?
Yeah.
Okay. One thing you could also look for is the F, going back to the slide. The T statistic should be greater than 1.96. So if you also don't use the p-value, you can look for it to see it. Okay. I'm not so sure I'm able to find the T statistic, but yeah. So we just kind of go by the p-value for now, for this simple linear regression. So are we all cool here? The reason why we are rejecting the null hypothesis. Okay. And now this assignment is also there, so kindly take note. So we want a table of the predicted, the actual distances, actual speed, sorry. Why are we predicting distances? Distance actually, so these two are a bit confusing. So what you are predicting is the distance, right? So we want the actual distance on one column and the predicted distances also on another column. Then we can just see whether we are deviating, and we can even create a third column and kind of calculate the distance. In that case, you can just square the results, the difference between the predicted and, so we can manually calculate the we can manually calculate one of these. Okay, we can, but I would want to kind of manually compute the are there any questions at this moment? If not, then we go to the part 2. And Joshua, do remind if I'm spending more time than usual, alert me so we can speed up.
Okay.
Are there any questions? And does everyone have now the data set I shared?
Yes, but please, how do we impute it? How do we run it?
How do you run what?
The data set into the R Studio. You know, you were just explaining, you asking us, you're not practicing. So you're a bit lost in that area.
Okay. Are you using R Studio locally or on the cloud?
I'm using it locally.
Okay. Locally. Okay. Tell me, are you able to launch, like when you go to file, new file?
Yes.
Let me know if you are able to do that.
Yes, I can see new files.
Okay. So in my case, I'm using R Markdown. Do you have that option?
Yes.
Okay, then you launch it.
It's not working. It's giving a bad sign.
Okay, don't worry about it. I think you don't have Markdown installed, so you have to install R Markdown. But just open the R notebook.
Okay.
Error. Sorry, please. Our notebook is also giving me error over here.
Really?
Yes.
Okay. Let me. Why don't you try the R Studio Cloud, and then you can.
Joshua, could you please help us with this video? How do we access our files, please? Those that have R Studio.
So you can actually do this in R. Okay, you can install the R Markdown package from. So the one who doesn't have R Markdown or getting errors, I don't know. Did you already install it? If not, do this and let's see.
Oh, Mr. Joshua.
Hello, Opeyemi, I can hear you.
Okay, could you please help us with how to access the files? People that have R Studio, that don't have R Markdown, that don't have R Cloud.
Okay, I don't want. Hello, Mr. John. Can I talk, please?
Yes, sure. Go ahead.
I think the question she's trying to ask is how she can import the data set into R.
Okay, so we are here to get there. Okay, right now I want to know if you are able to launch either R Markdown or R Notebook, and whether you've been able to kind of do this, at least view the head of the CAS dataset. Are you try this and let's see if it works for you.
I can't launch the R Markdown and the R Notebook.
You can't?
I can't launch the R Markdown and the R Notebook.
The other option, sorry, Mr.
The
John.
other option, so we have
the script.
Pardon?
Let them use the script to write the code.
Yes, R script. Yeah, launch R script and let's see.
Okay.
In my case, let me see what it will be. Okay.
Yes, I can launch it.
Good. So that should be fine. So if you you can rename it, I think. Where can I? Anyways, don't worry about it. So just like we were doing here, so you can then have head of cars. In this case, don't put any of these inside these things. It's not useful in your case. Okay, you just need what is in between those tags in your R script here. And if you put the mouse pointer in front of the text and you do Control Enter, I think it runs. Okay, and you see the result in the console. Are you able to do that?
Yes, I can do that. But what I saw at the end was on the console drop down were the values, speed and distance, 447789. If I'm right. Yes, same with yours. Yes.
Yes. Okay. So pretty much all these codes here that you can see, you can do them there in your. So you can even highlight Control Enter and it still runs. So if you want to differentiate between them, you can now do like maybe view head, view first 5 or something, first 5 summary. So something like that. And you can run multiple lines by highlighting all of them and then Control Enter. Okay. So once that is done, you can run the scatter plot in the R script. By putting the mouse pointer in front and okay, and it displays here. Are you able to do that?
Okay, it's giving me errors.
Whoa. What error are you getting?
Okay, for the summary class,
ensure you typed summary correctly. SUMMARY into
Yes.
brackets, cars,
Yes.
small letters.
Yes. All small letters.
And what's the error?
Okay. Yes. The summary was in capital letter. The S was in capital letter. Sorry.
Okay. So it works now.
Yes. The summary was.
Okay. So, and then,
Value, what does it really mean?
pardon?
The summary values, what does it really indicate?
Oh, the meaning.
Yes.
Okay, so the summary here is giving us some basic statistics like the mean of, for instance, this MIN dot here under speed is telling us the minimum value, the minimum observed value in the speed column. So that's what you have here, 4.0. The first quartile value of the speed column is 12. The median is 15. The mean and so forth, the maximum and that. So if you have many columns in the data set, it will give you the statistics of all, descriptive statistics of all those columns. So here we also have the speed column and it's giving you the same thing. So that's what the summary is used for.
Okay.
Good. Oh, sorry. Then we can also look at the scatter plot here. So you can highlight all these. We already, I mean, this is not the scatter. So splitting the data into train and test. So when you do this, then these variables are saved, so you can have access to them. So you can head over and also now do head of the training data. So as you can see, so when you do that, you are also able to see it here. I hope that you are following now, and you can also do this. Then you can fit your model as well. Good, so our model is fitted. We can do the summary of the model. Model summary. I think I'm gonna share this after, so you can just copy them directly and paste. So this also works as well. Good. And I can put all this here as well, but I have to comment them out. So are we all okay now? Someone couldn't also run our notebook, but are you also able to run it now? Hello, Joshua.
Hello?
Okay, I thought I dropped off. You can hear me?
Yes, we can hear you.
Okay. I was asking whether it's okay, we can continue.
Yes, we can. We can.
Okay, thank you. By the way, I like the questions that you are asking. So it means that we are having an interaction. That's good. So in case you have any question, don't hesitate. I mean, the reason why we are doing this is for everyone to be able to get the understanding and follow. So good. So the assignment is here. So before the session will end, someone with the solution to this would just kind of say it, so we all type it out and try. Okay, so we want to create a column with the actual distances in one of the column and then the predicted values in the other in a table like that.
That's it. How do you...
So pardon? Okay. So part 2. Okay. Now, if you launched R on your local machine, kindly put this data in the folder where you, well, let me see how you can check your, how do you check your directory in R? Joshua, you would like to help out on this so everyone can quickly get the data in the right folder and be able to import.
Okay.
So you can speak.
Oh, thank you, sir. Thank you, Mr. John. Can everybody hear me?
Yeah, I'm sure they are following.
Okay.
Yes, we hear you.
Yes, I think, let me quickly address this. We had a pre-class where we have attended to some of these basic issues. But I understand that not many people were chanced to be at the pre-class. But even at that, we still share the link for people to view after. So that aside, for us to now, I think we all have the data set with us with the extension .csv. So I think instead of us to save us the stress of writing the codes, when you download that particular data set, automatically to go to your downloads. So I would suggest to manage our time because we have like 30 more minutes. I'll suggest for us to manage our time. We just go to the section option at the menu bar. We go to the section and we go to work directory and we set our work directory to download. And from there, we can easily import our data set into R using the .csv extension. Thank you.
So you can also choose a directory where your data is located.
Yes, we choose directory and we set it to downloads.
Yeah.
Thank you, sir.
And so once that is done, if you are also using the RStudio Cloud, you would have to upload this. You would have to upload the data. Sorry, what did I just do? Files. So yeah, so when you come to files, on this side, I hope you can see my screen. So there's upload, and then when you click, you'll be able to select your data from your local machine. What's me? Okay. Don't worry about that. So that is it. And for the RStudio Cloud, when you upload the data, it will be in the current directory, so you don't have to worry about any other thing. So we can continue from here. Okay, practical 2, multiple linear regression. So we already talked about multiple linear regression. This is the case where you have more than one independent variable, like so, M1, X1, M2, X2, and so on and so forth. So, good. So this is e-commerce data set where, let me try to, good. So this data set, don't worry about the code. I'm interested in showing you. So it has some fields, avg.section length. This is the average session in store style advice session. Time on app is the average time spent on app in minutes. Time on website is average time spent on website in minutes. The length of membership, how long the person, how many years the customer has been a member. Okay, this is kind of an e-commerce platform. It has an app and a website. So the idea is to kind of find a relationship between the yearly amount spent and these other independent variables. By the way, we would be ignoring email, much interested in this. Okay, so the yearly amount spent is a dependent variable. So let's head over to our how do we import this data? So simply you could give a variable name, any name at all, maybe my data frame or something. In this case, I am using DF to represent data frame. And then with this less than and hyphen, which is assigning something to this variable. And use the read.csv. This quick, this it will still work, I'm not sure, but pretty much this is good. If you run this, you are good to go. Okay, and it has run. So if you successfully run this, then you should be able to. Sorry, you should be able to also view the first 5 lines of the data set. Okay. So it's here. We have the email address, avatar, pretty much what we saw on the other side. So these are the fields in the data set. We can also view Are you guys following? Because sure. Am I still online?
Yes.
What about the participants? Because I can't see the list. I don't know. Are they okay? Is everyone following?
Hello?
Yes, we are here, but it seems a little bit fast, but we are here, we are catching up.
Okay, good.
Okay. I was asking, are you all able to import the data? Because this is very important. If not, you won't be able to perform any of the actions after? Or
Yes,
below
I
it?
have been able to import the data. I have run the head. So that's where I am presently. I guess I'm catching up.
You see, I was not able to import the data. It was showing error.
Maybe
Okay.
she needs to put .csv into the command.
Hey,
Maybe she forgot to put .csv.
in the savings,
.csv.
Yes, I mean when she input the
No,
data,
we are saying don't
data
forget to
detail.
Are you able? Because this is very important. At least if you are able to import the data, then you are good to go.
Opeyemi, are you with us?
Mr. John, please proceed. Okwe was at the pre-class, so she would find a solution to that.
Okay, good. Sorry, I had to. And then we can also run the tail to see the last 5 rows of the data set. Okay. And as usual, you would always want to check, like run a summary to see what descriptive statistics you would have. So we kind of have, we already see that we have about 5 numerical fields. If you see these computed stuff, then it means the field is numerical. Else you can see class character. Class character just means that it is a string field, character field. I don't know what name to use. Yeah. So, and you can check the mean, max, median, minimum, and all those statistics for all the fields that are numerical. We can also check, sorry. Yeah, this kind of gives us an idea of the data types in the data. So if you run str and the name of your data frame. So here we get email. This is CHR, meaning character, and some examples, some of the values in that column. It gives, I think, yeah, as much as it can be in the line. We have address, which is also character. This is important because if you want to select some of the fields, for instance, in this case, we are interested in then running this is important since you the car. So here we see average section length is numerical because of this NUM number. Time on app is the number, time on website, and so on. So this already gives you an idea. If you want to pick out some columns, then you would have an idea of which ones have what data type. So it will make it easy for you. Okay. Now we would want to see, like, visually the relationship between time spent on website and the yearly amount spent. And I'm using the weight function. I'm sure there are other ways you could use to plot, but let's see how it looks. Okay, well, I don't know whether you say this is kind of correlating, but it looks so scattered here. So, okay. And then we can also check time spent on app, because this is time spent on website. So let's see the time spent on the app. And the yearly amount spent. So why is not running? Why is running? Oh, seems we have an issue.
Sorry.
Good. So with df comma plot time on app and then time spent, the yearly amount spent. So this also gives us like a visual relationship between the time on app and the yearly amount spent. Like I said, this dependent variable, and time on app is an independent variable. It's just one of the independent variables. We would like to just use the numerical columns. So this definition here is saying pick the data frame, all the rows, because there's nothing here. So it means I'm picking all the rows, comma, C into brackets, the columns, the column index, the column indices for the numerical fields. So let's go back and check. Probably we can use this. Arrow starts its numbering field. So we have 1, 2, 3. We don't want this one, but we want 4, which is the average section. So 4, 5, 6, 7, 8. We need these columns. So from 4 to 8, we need them. So that's kind of what I've done here. There's a better way. Probably we can get the names by using the code names, but that's much complicated for me or to a beginner. So you can easily just count them. But there's a much if you have a large, since this is sizable, this is okay. So called df underscore no, which will have 1, 2, 3, 4, 5 columns. So it has run, and we can, well, before that, let us check. Let's check the head. Yeah. Okay. So as expected, we see it starts from the average session length to the yearly amount spent. And there are 5 columns as expected. Okay. We can just use the plot function on the whole data frame to kind of do like a scatter plot for like a pair plot, you know, between the variables. So here, for instance, we have average session length versus itself. There's nothing showing, but average session length versus time spent on app. You can see the relation. Average session length versus time on website, you see. So this kind of give you a pair plot for all the variables. And you can see that, well, it looks like it's only this field, um, length of membership and um, length of membership and this and year spent. This is kind of a bit okay. So yeah, this field appears to be, yeah, length of membership and yearly amount spent. It's kind of, there's a very positive kind of relation. Well, this is also somehow, you know, yeah. So doing this gives you a visual impression of what to expect. So you see that at least we know that if for nothing at all, length of membership relates or has something to do with the yearly amount spent. But that's not to jump into conclusions. We are just saying this is what it looks, but we are not sure. Statistically, we can't conclude that there's a linear relationship between yearly amount spent and then length of membership. But that's what it appears to be. Okay. And we can now pick, well, this is, okay. Probably this is not very useful, so I'm just gonna ignore this for now. Okay. So let's leave this as they are. So we are going to, as we have already seen, we have 5 columns in the data set, with this being the dependent variable. Okay. So we are also going to split the data into train and test. I think this happens to be a better way of splitting. So you set your random state. In this case, we are using 1, 2, 3, and our training index can now be, we are sampling. I think this is an inbuilt function. I didn't make this up. If you have issues, if you run and it's not running, probably we will have to go back and try to use for the simple linear regression. But hopefully this works. So if you first have to run this to create the size, okay, 70%, and we now run that to also create the training index, and we now run it on the data frame to kind of split into train and test. And we have it also there. So we can check the head of the training data set. Okay, as you can see, so it worked. So we have and it's now 426 rows. If we check the whole data, okay. problem. So this gives us the training, the first 5 of the training data set. And now we also fit, we now build our model. Okay, take note of here, this is very important. In the simple linear regression, we only had an independent variable and then a dependent variable and one independent variable. But in this case, we have many of them. We have average session length, time on app, and so on and so forth. So what is changing is that in this case, your dependent variable still stands the way it would be as in the case of the simple linear regression, with this tilde there the same. And now for the remaining independent variables is to be an addition of all of them. So we have average session spent, average session length here, and then plus length of membership. So if you have 10 columns, you make sure to bring all of them. And then you also indicate your independent variable here. And then, so let me take this out. So when you run that, depending on the size of the data, it can take time, but I think it just finished. So we can also check the summary of this model. So we named it model, so we can just check. Good. So we have successfully built a multiple regression model. As you can see, this is the summary of it. And can someone tell me whether or not this model is significant based on any of these values you would like to use to explain? Who would like to try? Hello?
Yeah, I'll have to try.
Okay.
So from the coefficients table there, the p-value is 2.2 times 10 raised by minus 16. That's very low, lower than 0. Yes. So with that, we can reject the null and accept the alternative. That is, there is.
Okay. Okay. Good. Thank you for that. So usually these stars, so we have the average session length, the time on app, time on website, then so these ones would be telling us how important each of the fields are to the model, like how each of them contribute to the model. So the more you have stars at the back of the variable, it means that it is contributing to the model, So we can say that average session length is important. Time on app is this 3 stars, so it's kind of good. Time on website, as you can see, 0.37, no star. So probably you could drop this field and your model is still going to be okay. So it seems that it doesn't contribute much to the model. Yeah. So in general, if you check our p-value is, like he said, very small, which just means that it's by the look of it, it's less than 0.05. So we reject the null hypothesis. And yeah, so let's see what it means. So we have something here called the intercept, okay? And we have values. Sorry, I didn't show you that in the first model, but let's see what it means. So you remember we said that in the multiple regression, we are fitting something like M1 X1 plus M2 Mn Xn, where n is the Mn is the nth gradient of the nth observation, okay, plus some C. Okay. So okay. So this, we get estimate. So we see that estimate the intercept for the average section length. We have a value for the time spent on app. So we can kind of write a function like this. So y is equals to, in this case, y is the length of membership. I mean, the sorry, the yearly amount spent. So we can have this. Just trying so you see what it actually means, what we have done. So what is M1 and X1? So X1 is actually the first independent variable. So we have it here. But what is M1? So M1 is the estimated value for the average section length. So in this case, 2. So that's what the model was able to. This is the gradient that makes the standard error minimal. And we also have time on app being one of them. And what is the value? 3, this. And then time on website. So 0 point, this is kind of not very, and length of membership is also very useful, as you can see. Length of membership plus, and the value is 61. Good. Now, what is C? C is this, the intercept, like I already told you. So, plus this. So, I think that, okay, this is due to this dot. Well, the name doesn't matter. Let's just kind of. So, we have fitted this kind of function. Okay. So it means that suppose we are told that the average session length or for instance, let me just do the head of the test data and we'll see something. How did it be? Yeah, test. Okay. So in this case, we have 34.49727 for average session length. So suppose we pick this first observation, okay? We want to know what our model will predict for yearly amount spent. Suppose that the average length is 34 point this, time on app is that, and that, and that. So we want to know what our model will kind of predict for this first column. In that case, we are going to have here something equals. So the values here, so we have 34 point that times the value, the M that our model was able to fit, you know, something like this. So, okay, plus the time on app is this value. So, and then our gradient was, sorry, this one. Good. So that's pretty much what we are doing. So in predicting, using your model to predict, you kind of now put the fitted values of M of C and the M's inside the function, the general function that you have put here. So in this case, you now replace the unknowns by what is observed, and then you kind of get your predicted y. Let me put this where here. So good. And then we have, so here is time on website. So and by the way, I will give you the original source to this work. I didn't do this. So I kind of when I was also a beginner learning stuff, I came across this resource, and it's useful, kind of not very complicated. So it explains a lot of the basic stuff. So I'll be sharing the GitHub link with you, so you can just go check it out. Plus other resources there as well. So we also have this, plus the. Did I miss something? So we have that. Time on app. Time on website. So time on website is 39. and then plus this is okay times 4 point that. Good. So if you kind of compute this, which we can, I don't know what R can do for us. Let me see. Let's try to see what. I'm sure we can run this, right? Should get to. So if we now check what value we had for good. So what did we get? What is our model predicting? Good. So we get 1,647, while the actual observation is that 532. You know, so this prediction is kind of way off, but it's normal since these all contribute to the model not being perfect. But if you continue to put in the other observations, you are pretty much going to find some of the results closer to the actual observed values. So what we computed in the, what we try to minimize, like I was talking about, is this, for instance, or that, or that. So as we have seen in the prediction, we had this. Meanwhile, the observed value is that. So what is the difference between this observed value and the predicted value? So we kind of find the difference and square that. And for the for the next observation, we also find the difference and square. At the end of the day, we kind of add all of them and then find the mean. I mean, divide by the number of observations. So actually, that is what we are trying to do here. At this point, I think that we've come to the end of the second part for using R to build a multiple regression model. After the break, we can look at Python if there's time, and then take more questions and probably some assignments. But I'm ready to accept some questions now before if there's a break. Thank you.
Okay, thank you very much, my great speaker, trainer, Mr. John Bagiliko. Please, I mean, just to manage our time, I don't know, please, we might just have to keep questions till the tail end. We initially had the mind of stopping by 1 p.m., but I can see that most of the participants are enjoying the training. And if I should tell them that we are stopping now, they might actually fight me, but I don't want to be beaten. So we'll just have like, maybe we can just pay like just more 30 minutes and go through the how we can do this using Python, like a run through on how we can do it through Python. And when we are doing this, there won't be any talk from the participants until the last part, which will just be for question and answer. So just give us a run through on how we can do this on Python.
The Python is going to be pretty quick. I'm not going to be running, and it's not my notebook, like I said. So I'm just going to do a walkthrough. Okay, the idea was to give general overview, you know, the understanding. So I'm just going to quickly do a run through the model. Okay. And then, so this was originally built by Amidali. Okay, so and you can, I will share the link. You can check the original source. So basically, what we usually do in Python. By the way, is there someone trying to run this right now in a Jupyter notebook, as in Python, running Python right now? If not, it would just be better for me to do a walkthrough and share this document. Then you can do it at your own convenience.
Yeah, that'll be fine.
Okay.
That'll be fine. So yeah.
Yes. Cool. So we start by importing some useful libraries, that's pandas, NumPy, matplotlib, and seaborn. Okay, and well, pandas is usually used for data frame manipulations, NumPy for statistical stuff, matplotlib for data visualization, as well as seaborn. This matplotlib inline just means that it displays in the notebook here. Right? Okay. So we've already gone through to have a look at the data, so we understand. So in Python, in R, you would usually do just read.csv. In Python, we are using pandas to kind of read. So pandas dot read CSV. So this function is inside the pandas module. So, and you, as usual, put the name of your data, and you assign it to a variable. In R, it is a less than sign with hyphen. In Python, it's just equal sign, and you are good to go. So we also name it df, and we can visualize or look at the first 5 by using df.head. Unlike in R where you have head of. Okay, so this is a difference. In R, you will do summary of the data frame to kind of get the statistics. In Python, you do df.describe. So we also see that here. And in R, when you do str of the data frame to kind of know the data types of the fields and stuff like that. In Python, when you do df.info, you also get a similar result, giving you an idea of the data type. So we have object, object, object. So object is just a string field, as in why do I keep forgetting this name? So it's a string, categorical. Thank you. And you also see the other fields. So we have float. You also have int. Sometimes if it is an integer field. Good. These are some visualizations that you can look at when I share this with you. So we are using Seaborn to kind of do a joint plot. Sorry, the time on website and yearly. I don't know why R kind of truncated the column names and put dots, but Python still kept them like that. So there are spaces in the name. So R kind of truncated them. So take note of that when you do the code. And sure, when you do this, you kind of visualize. At the same time, it gives you some bar graphs. So as we can see, Python, Seaborn is kind of visualizing it nicely. There's a way you could also use Seaborns in R. but you have to install some library. Don't worry about it for now. And we do same for time on app and yearly amount spent. And also you see that this has a better kind of linear relationship. And time on app versus length of membership. Well, this would be better. You just do the SNS.pair plot of the data frame. When you do this, it also gives you a plot of all the numerical values. Yeah, as we saw in the R, but for R we had to kind of specify the numerical columns, else it would still put some funny graphs for even the categorical fields. So that's something and you could also do like try to fit some line and see for the length of membership and yearly amount spent, since we saw that it's kind of highly correlating. So we try to see what the best a line can fit in it. Okay. Training and testing. So in Python, you kind of have to separate your X variable from the Y. So that's what I was trying to do in R initially, and so that it kind of, so for R you can just put them together and specify which one is your X and which one is your Y during the model implementation. But here we need just the average session length, the time on app, time on website, length of membership, because these are what we need and they are the independent variables. So we assign them to X and look at the way we do it, df of double braces, and then you specify the names of the columns in quotes, and you assign the dependent variable to the Y. Okay. And we also have scikit-learn, which you have to install if you are using Python. After you install scikit-learn, you'll be able to import the cross-validation module. And in it, the train test split, which we used to just kind of split data set into train which one of X, so we already have our X and our Y, and then the test size. So this is a ratio of what you would like to reserve to be used as your test. Kind of is now 0.3, so that's 30%. And the random state is also important, like we were doing in R, just to be sure that different people running it in different environments will get the same result. So we are about to train our model. In R, you just have to use the LM. In Python, by using the scikit-learn, you would import linear model, and in it there is linear regression. So scikit-learn.linear model imports linear regression. So, and you have to kind of initialize it. So we are initialize it with with LM. Okay, pretty much the same as we had in R. We had LM, so we kind of just assign LM to linear regression and use it to fit X train and Y train. it is we are putting them side by side. So X train does not contain the Y field. So if you put them together this way, then it matches, every observation in the X, you have the corresponding Y in the Y tree. So something like that. And that's all you need to do, and your model is fitted. And you can check some of you can check the coefficients, just like we saw in R, which we were even able to copy and paste in the general model. So we have pd.data frame, you put it in a data frame. But simply when you do lm, the name of your model dot coef underscore, it gives you the coefficients. Okay, but we want to put it in a data frame. So this name, and then the column name, so that we put it in a data frame. So we have the average session length. So we have row givers. Yeah. So R gave us 25.8344, and Python is giving us 25.9815. So they are kind of close. And then we predict on the test data set. And the way you do it is just lm.predict the name of your test data set. And then you have it there. So we can kind of do a scatter plot of the test values, which is the observed Y values, which is the observed, what's the name of the column? That's the yearly amount spent, is our Y. So we are able to kind of do a scatter plot of the two, the predictions versus the Y test, to see, and we see they are kind of, some are intertwining, kind of making close predictions. So you kind of are not able to obviously differentiate. So it's kind of good. And some of this evaluation metrics we talked about, the mean absolute error, the mean squared error, the root mean squared error. You can easily achieve that by importing the metrics module from scikit-learn, and you do metrics.mean absolute error of your Y test, comma, the predictions that you make, and for the others the same, and it gives you this kind of. So your homework could be to see how you would print out those p-values and all those other statistics, if they exist in this scikit-learn model. So you can go check out the scikit-learn documentation to see how you can achieve all those other things to know whether to reject or accept your model. But if you have to compare two models, then you can use this. Because if you just build one model and it gives you a root mean square error of this, I mean, what does it mean? I don't think you have an idea. Whether it's good or bad, you do not know. But in case you are comparing two models, then you can, this kind of makes sense. And like we said, these are there to let you know mean squared error, the lower the better, and stuff like that. So, So yeah, on a high level, this is it for the Python. And when you do a plot of the residuals, that's the errors, that's the difference between the observed and the predicted. And if it gives you a close to normal distribution, then it shows that your model is kind of good. So as in this case, you can see we have a kind of normal distribution for the residuals, which is good for the model. So I know this is fast, but I will share this document with you so you can easily take your time and go through, and hit me up on LinkedIn, Twitter, or any other social media platform, and we'll be in touch. Thank you.
Wow, thank you so very much, Mr. John, for that beautiful section. We are so glad. Like I used to say, I used to tell people, I said, I'm also coming to the training to learn and not just to facilitate. And I think at the end of this class, I've been greatly blessed. And I'm sure every other person is been blessed. So I just want, before Mr. John goes, I just want to give room for, our time is fast spent. I just want to give room for 2 questions before we go into some observations and we close for the day. Just 2 questions. If you have questions, please just raise your hand. We'll see that and we can give the floor to you. Any question before we close? Just 2 or 3. I'm not seeing any hand raised.
I'm sure they are focusing on the R.
Okay. If that is the case, then let me appreciate every one of us for joining us for the first.
Sorry, Prof. I appreciate the fact that our teacher could take us through the Python interface. Okay. But I just want to quickly ask that, is there a setup for the Python, or we have to access the Jupyter through our normal browser? Just to quickly ask that one.
Okay. Don't let me talk. Okay. Mr. John, over to you, sir.
Yeah, so what you just have to do is to install Python. You have to install Python, and you install Jupyter Notebook if you want to run it in this kind of environment. So if you have Jupyter Notebook installed, you can open, whether you are using Windows or Ubuntu or any other machine. Once you have Jupyter Notebook installed and you type Jupyter.notebook, you can launch it. And when I enter like this, it's going to automatically launch a browser for me. And I can select where my data is to be able to. Okay. In this case, my data is here. Okay, so I can come here and create a new Python 3 notebook. Yeah. Oh. And then I can print hello world.
Okay. Thank you very much.
Something like that. If you have issues, I'm always available. We can. This was the match. The focus was much on the R. This is kind of to give you an idea of some of the things that can be done in Python. So hopefully once you get it set up and you can run these commands. Yeah. I don't know if I was able to answer his question.
Are you okay, Mr. Bankole?
Yes, sir. You answered my question very well. I appreciate you, sir.
Oh, thank you very much, sir.
Thank you. Yes.
We'll take like 1 more question before we go. Just 1 question.
Hello, Mr. Joshua.
Please go ahead, Mr. Shegun.
Okay.
Mr. Shegun.
Yes. Yes, sir. My name is Sheikh Oladoye. I just wanted to
Doctor,
ask whether the data and the code will be available for us to use.
Sorry, sir. It will be available, sir.
Whether the code and the data will be available.
It will, sir. It will be available.
Yeah.
So that's just my question. And the code too.
Okay, it will be available.
Both Python, R, the slides, the data, everything will be made available.
Okay, I think any other question again? Just one more question before we go. Okay, in the absence of no question again, I want to once again appreciate Mr. John Bagiliko, my good friend from Ghana. I want to appreciate you for the efforts you've actually invested in coming up with these beautiful materials you have prepared and this great section. We are glad and we are grateful on behalf of TAG NG. One thing I want to say before Mr. John goes back is that I think we met on LinkedIn, and since we've met on LinkedIn, we have been working hand in hand, we have been learning, exchanging ideas, and I want to tell every one of us that are present that this, like what Mr. Dixon told us, this is just like a tips of an iceberg. What we are doing is like a long-term project to make popular the usage of our among Africans, most especially undergraduates. So what we'll be doing, what we're also trying to incorporate is that we also want to carry along the lessons on Python. I mean, from the scratch down to the advanced level. And so when we have any other trainings again, we'll be carrying us along. I noticed today, and I wasn't really happy about it. We had a pre-class, and at the pre-class, most of the questions that were raised have been attended to. I think I was the one that took the pre-class, and I knew the issue of setting work directory it's something very important. So I stressed that part. So, but I see that we kept on asking that question again, and I want to appreciate the trainer for his patience. He was patient to address individual questions. Thank you very much, Mr. John. So in the case of, to guide against this in our next training, please, I want to beg, if we have any suggestions or want to ask any question, you can raise your hand and you can talk. That is only the question and answer segment. And when you are done talking, please do ensure that you unmute yourself again so that we can have like a perfect learning environment. So the next class will be coming up next Saturday, and it's going to be like an interesting time. I don't want any one of us to miss it because we'll be having with us next week Mr. Martin Bagara. He is a PhD candidate from the University of Washington. We've talked at length, and I know that it's going to be like another mind-blowing section next week. We're going to see another dimension of this AREFOR, AREFOR 2020 is going to come up in a greater dimension next week. So I don't want any one of us to miss it. And just to tackle some things that arise today, we are coming up with another pre-class again on Wednesday. So we'll still be using this same link and the code that was shared to us on the personal notes to connect for the pre-class on Wednesday, 10 a.m. GMT +1. We'll be meeting again on Wednesday before the class on Saturday, just to prepare us ahead of what Mr. Martin Bagaram has prepared for us, and to do away with some questions that can, slow down our pace. So please don't let us forget that we'll be meeting again on Wednesday, 10 a.m. GMT +1, and maximum 10 to 1 hour will be through. 1 hour or maximum 1 hour 30 minutes. So once again, I want to appreciate everybody on behalf of the members of TAG NG. And I also want to appreciate some special people that are with us. Some of my mentors are here. I don't know. So some of my mentors are here, and I won't want to mention name. I won't want to mention name. I just saw somebody, I saw senior. I said, I don't know, this is my gal. So I want to welcome our special people, our great people, and every one of us too, we are all special. Thank you for your time, and God bless you. Good day.
Good day, everyone.
Thank you. Bye-bye.